one doesn't think about Nobel Prizes all that much, when you're working at the bench. You're interested in what you can do. I mean, I was excited that I could get a peptide, and I extended that a bit, and I got some more sequences at the ends of the chains. And I think the main consequence of it was that then I realized that it was possible to do more sequencing, and to do with other colleagues and things, we actually completed the complete sequence of the insulin, which took quite a lot of time, but it did put me on the road and really decide my future work. And all my work, or all the work that's really paid off, has been on sequencing. Initially, the proteins. It's really mostly involved in finding methods, really, finding out how to do it. And it does depend very much on other work in other labs. I mean, in the case of this end groups, it depended very much on the work of Archie Martin, who was a rather brilliant physical chemist, and he invented a method of fractionation. This, I think I've already mentioned it, this partition chromatography. And then later on, he developed another method, the two-dimensional paper chromatography, where you can just put your stuff on a sheet of filter paper and run solvent through the paper, and you separate all the small fragments, peptides, little bits on the paper. And we did a lot of this, and cutting out the spots, seeing what amino acids they contain. So you got little fragments, and then you had to work out how they could be fitted together. Bit of a jigsaw puzzle sort of a thing. Call it the jigsaw puzzle approach, fitting little bits together. And that was essentially the method that was used for protein sequence analysis.